Hey students, this is lesson 1-3, real numbers and the number line. We're going to learn how to classify, graph, and compare real numbers and to find and estimate square roots. Go ahead and do this review and I'll check back with you. I'd like you to know a few more perfect squares than these, so let's add a few more numbers. Let's add 13, 14, we'll go all the way up to, let's go up to about 20. You should know all of these square roots and perfect squares. So 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. I think you should also know that 25 squared is 625. All right. A square root, just as a reminder, is whatever number multiplied by itself equals that number. And there's actually two square roots when you think about that. Like if I said, what are the square roots of 25? 5 times 5 is 25. So 5 is one of the square roots. And also, negative 5 times negative 5 is 25. So negative 5 is the other square root. If we write it like this, the square root of 25, without a negative sign in front of there, then we're talking about the positive square root of 25. So since 5 times 5 is 25, the square root of 25 is 5. And so now in this next one, we're looking for what number times itself is 4 over 81. Remember, to get 4 over 81 in multiplying fractions, we need two numbers multiplied together that equal 4, and that would be 2 times 2. And then we need two numbers multiplied together that equal 81, and that would be 9 times 9. So the square root of 481st, the positive square root, is 2 ninths. All right, I'll let you try that. All right, so we're going to estimate square roots here. It says, what is approximate side length of a square that has an area of 220 square inches? Just as a reminder, a square is really a rectangle, and the area of a rectangle is length times width. For a square, both sides are the same. So for a square, we can just say side times side, or the side squared for the area. So we want some number multiplied by itself that equals 220. And that number is actually the square root of 220. Now to approximate that, we're going to go back to what we remember on the first page. And you might have just written this down, so we can just go back and look if you want. We wrote down a couple extra square roots. We know that the square root, we're trying to get 220. 220 is between 196 and 225. So we know our answer is between 14 and 15. And we know that 220 is closer to 225 than it is to 196. So the square root of that, of 220, is closest to the whole number. So we have the square root of 225, it's 15. We have the square root of 196 is equal to 14. And since 220 is closer to 225, we're going to approximate this approximately equal to 15. All right, I'll let you try that using a number line. Go ahead and fill in the values. Okay, here's an important concept. You can classify numbers using sets. A set is a well-defined collection of objects. Each object in a set is called an element of the set. A subset of a set consists of elements from the given set. So we're going to deal with certain sets of numbers, and you need to know these. Our natural numbers are just like counting numbers. You start at 1, 2, 3, and so on. Whole numbers are counting numbers and also 0. Whole numbers start at 0, and then they go up. Like counting numbers by 1. Integers are positive and negative whole numbers, so there's no decimals on these, or fractions. And a rational number is any number that you can write in the form a over b, where a and b are integers, and b is not equal to 0. So if you can write the number as a fraction, you know that it's a rational number. Like if you can, when you divide 7 by 3, that's a rational number, and that's equal to 2.3 repeating. So repeating decimals are also rational numbers. Now, if it terminates, like say 5/4 as a decimal, that's 1.25. That's also rational numbers because we found that number 1.25 by dividing two numbers. All right. So numbers that aren't rational numbers are ones that, as a decimal, either don't repeat and don't terminate. They don't repeat and they don't terminate, like pi. Pi is not a rational number because the number never repeats as a decimal and it never ends or terminates. So this is negative 1.75, which as a decimal it ends, so that is a rational number. Square root of 5 is 2.23, and that keeps going on and on with no pattern. So square root of 5 is not a rational number. 0.9 repeating, that repeats, so that means that there is two numbers that you can divide to get that, and it turns out that the two numbers you can divide to get that are 9 and 9. You may think about that they're not actually the same, but they are. 7.35, we can write that as 735 over 100, so that is the ratio of two integers, so that's rational. All right. If it's not rational, they're called irrational. So we're going to use these sets and decide which of these sets the real numbers belong to. 12, that's a counting number, so it's in the naturals. 12 is, all natural numbers are in whole numbers, so it's also a whole number. It's an integer because all whole numbers are integers. And it's a rational number because we can write it as the ratio of 12 over 1, the ratio of two integers. So it's all of those. This decimal number ends at 9, so that means we could write it as the ratio, and I'll do that quick for you just so you believe me. If I write it like this over 100,000, that will be the same as that decimal number. So that's a rational number. Obviously, it's not whole, and if it's not whole, it's not an integer, and it's not a natural number. So it's just a rational number. Square root of 21 on your decimal, you're going to want to do that, and you're going to find that as a decimal number that never ends, and it's hard to tell that on your calculator, but the square root of 21 is 4.58257569, and then it just keeps going on, and there is no pattern. That's just an irrational number. All right, so I'm going to let you try and order these by checking off what fits and what doesn't fit. All right, the concept summary here. We want to order these. This is really a Venn diagram here. And notice it's there's a certain hierarchy here. If it's a natural number, notice that's inside whole number, so it's also a whole number. The number up here in this list that's a whole number is 0, so we're going to put that there. And then our integers, remember, can be negative numbers. So the one number up here that's a negative number but it doesn't have any decimal on it, that's that one. Any terminating or repeating decimals or fractions, they're going to be our rational numbers, so we're going to put those here. 3/7 and negative 5.43. And notice we're going to draw a line here. If it's any of those, it's not an irrational number. Irrational numbers are numbers like 5 and square root of 7. All right. Comparing an ordering number. What is an inequality that compares these two numbers? To compare numbers, we're just going to write those as decimals and then compare the decimals. So we need to approximate the square root of 34 to a couple of decimal places. 5.83. That should be enough because 5 and 4/5, if we do 4 divided by 5, we get 0.8, so that's 0.8. Put a 0 so we can match them up. So obviously this number here is greater than the other one. So we're going to say the square root of 34 is greater than 5 and 4/5. All right, I'm going to let you do that and finish up the rest. It's more ordering and graphing, and you can check back with your answers. And also you should do the lesson check and share that with class. So I'm going to pause here, give you the answers, and then that'll be the end of the video. Notice I changed them to a decimal approximation so it'd be easier to compare them and find them on a number line, and then I ordered them. All right, go ahead and do the lesson check and be ready with your answer, and I'll see you tomorrow.